Hey everyone, welcome to another video. Now today we are talking about lines with one intercept. Now this topic is also sometimes commonly referred to as horizontal and vertical lines because from what you can see in this photo I've attached, we are dealing with perfectly horizontal or perfectly vertical lines. They're no longer slanted and drawn like this, for example, or like this, which we may have been used to up until now. So, with these types of graphs, they're actually, in terms of their equations, they're not too difficult, but I want to spend a little bit of time just explaining and giving you hopefully some intuition as to why these kind of look the way they do. Now, I'm going to move this over to this side, and I want to first look at this line here, this horizontal line. Now, taking everything we know about linear relationships, we know a couple of things that we're going to apply to this line here. So I know that all linear relationships have the form of y equals mx plus b or plus c. And I can write all of them in this form if I'd like to. We have general form, we have what we call gradient intercept form, but let's just work with this particular thing here. This is what we call gradient intercept form for equations of lines because, as you may have guessed, they tell us the gradient and the y-intercept. Now, just reading off this particular graph, what is the y-intercept here? Well, it's going to be this point here. When x equals 0, my y equals -2. So one line I can fill in as, well, this is going to be y equals our gradient as the coefficient of x plus -2. Or we can just write this as mx minus 2. Okay, cool. And we have here a gradient. Now, if you remember from the content in the last year of linear relationships from the year 8 series, well, our gradient tells us how high the graph goes for how far along in the horizontal length it goes. So it's pretty much a ratio of rise and run. So how much a graph goes up for how far it goes across. Now, this particular graph here, if we compare it to a graph like this, for example, I have some kind of gradient. As I go up by 1 in the x, I go up by 1 in the y. As I go up, I have this kind of constant gradient going all the way through my graph, right? And the slant, the slope of that tells me that. It tells me that, okay, there's some kind of ratio between the rise and the run. How far it goes up versus how far along it goes, how far it runs across in the x direction, along the x-axis. Now, let's look at what this graph's doing down the bottom, because this looks kind of wacky, right? What it's doing, well, it's definitely running. It's going along the x-axis, but is it rising? Well, it's actually not. It's staying on -2. So there's a run, but there's no rise. So let's take, for example, from here to here. My run, so if I wanted to come up with my gradient, that's my rise over my run. Now, how far have I run from these two red dots? Well, I have gone 1 unit. And how much have I risen? I've risen 0 units. So if I do 0 divided by 1, what does that give me as my gradient? Well, it gives me 0. So a gradient of 0 here means I'm going to get y equals, instead of m, I'm going to substitute 0 times x minus 2. But what happens here? in my 0 times x, that is going to kill off to 0. So I can say that my y equals -2. That is my equation of the line. And we can interpret this in another way as well. I can also interpret this using another thing I learned in Year 8 linear relationships, and this is the idea of a table of values. Now if you're not fully convinced yet, that's all good. Let's make a table of values with all of these points here. Let's just pick a few. So I have this point here, that's going to be -2 in the x, and it's going to be -2 in the x and -2 in the y. This point is going to be -1 on the x, -2 in the y, and this is going to be 0 in the x and -2 in the y, and so on and so forth. But let's just make a table of values here using these points. So I have x, I have y. My x coordinates are going to run from -2 to -1 to 0. And my y points are going to run from -2 to -2 to -2. So you can kind of see here, hopefully, that my y, it has no relationship to x. Because as x changes, y doesn't change. Y is independent of x. So as x goes up +1, my y is going +0, +0. It's actually not changing at all. So I can say no matter where along this line we go, there's no relationship between x and y. The only thing we know is that y is always -2. No matter where we go along this line, y is always -2, independent of the changes in x. So we can write here, with this piece of information we got, that y is always -2. And how can we write that? Well, we can write that as y is going to be equal to -2, which is the main takeaway from this particular exercise. Y equals -2, and that is the same thing we got here for our gradient idea. And now the same thing applies for the x here, because if we consider all of these points in my table, if I made, say, a table of values, well, I'm going to get that this point, for example, is going to be 3 and 3. This point is 3 and 2. This point is 3 and 1. Now, if I make a table of values with all of these points that I've selected, 1, 2, 3, on my second graph, my second line here, my vertical line, I would have this table of values. I would have x, y, and that was 3, 3, 3. And my y value changed. It went from 1 to 2, to 3. So let's look at how these are changing. Well, my y is changing, but it has no effect on my x. Because my x, we're always adding 0. In other words, we are never moving from 3. No matter what changes in the y, x is always 3. So I can write that my equation for this is going to be, x equals 3. because there is no relationship between the x and y variables. No matter what happens in y, my x always runs along this x equals 3 coordinate. In all of these points here, my x coordinate is always going to be 3. So this is what we mean when we look at these lines with one intercept. It's this idea that there's no x and y intercept. There is only, for example, this line, it just has an x intercept. And this line only has a y-intercept. And that's where we get these equations from. Here, my x-intercept equals 3. X equals 3. But x equals 3 all the way along. So I can write this as, for example, x equals 3. But down here, my y-intercept is -2. But my y is actually always going to be -2. There is no changing happening depending on the x. And we saw this from our rise over run example at the start of the video. So these equations, in finding the equations of these types of graphs, all we have to locate is the intercept. And that tells us what our equation is going to be, which may seem to some people counterintuitive, because here the line x equals 3 is a vertical line, and we often associate vertical with the y direction. But if we think about this as, well, x is my intercept, and it's kind of going all the way through this intercept, that helps hopefully to eliminate a little bit of confusion. But I'll just do 2 quick examples just to show how we can sketch these vertical and horizontal lines. So 2 questions. I want to sketch the graph of y equals 3. And we can do that really quickly, guys. We have our y, we have our x-axis. I want to find, well, where is y equals 3? So if I have 1, 2, 3, my y-intercept happens at 3 here. So my line and my y is always 3, no matter what x does. So I stay on y equals 3 all the way through my graph. Y is always 3 all the way through. Now let's do another example. X equals -4. So we want to locate -4 here. We have -1, -2, -3, -4. And I'm going to say, well, let me label these graphs too. Y equals 3. And all I have to locate is my x equals -4. The point along the horizontal axis when x is -4. So that's here. And it's going to be -4 no matter what y is. Whether y is 1 or 2 or 3 or 4 or any number, I'm always going to have -4 as my x. So that is going to be how I draw this line. But that is how we can think of these lines with one intercept, these horizontal or vertical lines. We are just thinking of, there is no relationship between my x and y variables. One of them is just constant all the way through. For example, here, my y was always 3 no matter what x was. Here, my x was always -4 no matter what y was. Thank you so much for joining me today, guys. I'll see you in the next video.